Data by itself are bits and pieces of information that cannot be interpreted without being analyzed. Say, for instance, names in a telephone book such as John Smith, this is a piece of data that would be meaningless without, say, for example, his telephone number. Right? Each piece of information alone is meaningless, but it's only once we put the two together that it becomes something important. We know that John Smith's phone number is as follows, and that this phone number is related to John Smith. But without one another, there is no meaning. In the business world, companies spend a lot of money gathering data, such as research and development, so they can process it into information that will allow this company and its decision makers to make intelligent choices for the company's future. Say you're a marketing student. Data collection is extremely important because the accuracy of the data you will get will have a huge impact on the reach of marketing efforts. Or say you're a finance student. You will need to interpret a variety of data and information in order to value investments. It must be clear for everyone that statistics is important in the business world, regardless of the field you're in. In essence, information is meaningful data. Thus, statistics consists of analyzing large quantities of raw data and converting it into useful information. The main question is, how do we convert all this data into meaningful information? There are various ways to accomplish this in business. A little further on, we will see there are descriptive statistics, and these consist of a few things. So first off, we have charts. There are a variety of charts that we will use. We will have simple bar charts, which are used for categorical data, such as, say, for example, the countries. So we have Canada, we could have US, and so on. So these are bar charts. We also have pie charts. So pie charts represent slices of a whole. So we could have, for example, out of the entire population in Canada, we want to know the percentage of the population that is from a certain ethnicity or another. Also, we could have histograms. So these are also bar charts, just a little bit different because these take on classes. So these take on numerical values. So we would have, let's say, for example, from 0 to 2, from 2 to 4, and these classes, and so on. And the second method that we use is the statistical inference procedures. Now that we all distinguish data from information, let us briefly discuss how we collect data in the first place. The main categories of data collection methods are experiments, telephone surveys, written questionnaires and surveys, and direct observations and personal interviews. You've probably covered most of these in class, so we will simply highlight the importance of understanding the advantages and disadvantage of each one in order to make the best possible business decision according to the given context. So this brings us to the data collection issues. These are data accuracy, interview bias, non-response bias, selection bias, observer bias, measurement error, internal validity, and external validity. So once again, we won't go into detail. These are very well covered in your textbooks and in your materials. We simply want to highlight the importance of once again understanding the advantages and disadvantages and knowing how to describe the issues properly. So this brings us to the actual process of collecting data. Because companies often face budget and time constraints, they will not observe the entire population defined as seen here, all elements of interest. Instead, they will segment the population into a subset called a sample. So say, for example, I just want this subset right here. This would be a sample within my entire population. So this sample would be representative of the entire population. In order for the sample to be accurate, ideally that is the characteristic that we're looking for. Population values are known as parameters. Whereas sample values are known as statistics. There are many ways of segmenting the population into sample. There are two sampling technique categories. The first is called the statistical methods. And we also have the non-statistical methods. We'll start with the non-statistical as they're a bit simpler. There's only two, which consist of the same thing. The first is through judgment, and the second is through convenience, or human-based criteria. So the idea behind the non-statistical methods is that we're simply using our own judgment. There is no mathematical or statistical procedure in order for us to segment our data. Whereas the statistical methods involve a specific selection criteria. So for example, if we take the first one, which is simple random sampling, this implies that each sample has an equal chance of being selected. So let's say from our population here, let's say there are a total of 30 individuals, then that would mean that each of the 30 individuals has a 1 chance in 30 of being randomly selected. Now moving on to our systematic sampling. This simply implies that out of our say 30 individuals, once again, we will be selecting 1 every 3. So let's say, for example, I'll be selecting this person, and then I'll skip about 1, 2, 3 heads, and I'll select this person. I'll skip another 3, 1, 2, 3, and I'll take this person. So that's systematic. Systematic, we have a certain rule that will apply, and here is every 3 people, for example, and that's how we will sample. Finally, we have stratified sampling. And if we look at this picture right here, a strata simply implies that the population is divided into various strata or various different brackets. This could be seen in income tax brackets, in salary brackets, in social status brackets. We could have this for a variety of different things. And the way it works for stratified sampling is that once the population has been categorized into the different stratospheres, so we have here, let's say 1, 2, 3, and our 4 strata, in each strata, we will apply any of the other sampling techniques. So it could either be our simple random sampling that we saw before, or systematic. The idea here is just that we will apply a sampling technique to one given strata or one given bracket at a time. And finally, we have the cluster method of sampling. And as we can see from this image right here, the fun part about cluster sampling is that, say we can't reach the entire population of Canada, we will take a cluster, say simply a cluster within the province of Quebec, and we will sample the entire province of Quebec, or as much of it as we can according to our budget and our time constraints, in hopes that within that given cluster, all elements of the Canadian population are found. So let's say, for example, all age categories, men and women, different ethnicities, and such. So the idea of cluster sampling is to go beyond geographical boundaries, but within a limited time constraint and budget. And finally, there exist different types of data. Data can be expressed either in a numerical form or in a descriptive form. So in a numerical form, let's say, for example, my age, whereas in a categorical form or descriptive form, something about me would be, for example, my gender. So what is a numerical value is referred to as quantitative data, whereas what is a categorical or descriptive value is referred to as qualitative data. In addition, data is considered being time series when it is collected over time. So say, for example, we have time here on the horizontal axis, and we would have salary on the vertical axis, and I could plot my salary over the years. So this would be time series data. Whereas cross-sectional data is simply taken at a given point in time. So once again, say we would have salary. And then we could have for, say, all the employees, we could have their salary for a given point in time, say 1 month, which is just the month of January. So once again, cross-sectional is at one point in time, whereas time series is across time. And last but not least, we have different data measurement levels, all the way from nominal data to ratio. So let's go over them one by one real quick. The first type would be nominal data. Then we would have ordinal data, followed by interval data, and lastly, ratio data. So let's give a quick example for each to illustrate what each one is. So nominal data is simply any given qualitative data that is presented to you in a survey. So say you would have, for example, your status in terms of relationship. We could have single, married, divorced, or engaged, let's say, for example. Okay, so these are simply 4 qualitative values that could be assigned in a survey. There's no particular order to either one of these 4. You do not have to be married before being single or divorced before being engaged or so on. There's no particular order. It's just 4 values and you would select one of the 4. Now the difference between nominal and ordinal data is that in the case of ordinal, as the word suggests, there is a given order between the qualitative values. So say, for example, we would have, within a given survey, you would agree with something, you would strongly agree, or let's say at the very end, you would disagree. Okay, so you agree with me that there is a given order. So as you can see, there is an order to this data, which happens to be wrong. Disagree would have to be here in the front. So we would disagree with something, then we could agree, and we could strongly agree. There is a certain scale to the level of agreement that this survey presents. So this presents an order, which is the difference between nominal, which is just the words in any given order. Now, one more thing that's important to highlight, these 2 here are for qualitative or categorical data, which leaves us the last 2, which, as you can imagine, are for numerical. So let's cover the last 2. So for interval data, this simply implies that there's an equal distance between values. So say, for example, GPA. So we would have GPAs from 0 to 1. The next GPA over would be from 1 to 2. And then finally, let's say from 2 to 3. So as you can see, there is an equal distance between each of our intervals, and there is an order to our intervals. So interval data is ordinal by definition. So our GPA scaled from 0 to 3 and not from 3 to 0. Okay? And finally, the difference between ratio data and interval data is the true 0. So let me explain that real quick. If we have temperature, say 35 degrees Celsius, and then say we have 75 degrees Celsius, this is not comparable to 35 degrees Fahrenheit and 75 degrees Fahrenheit, because temperature does not have a true 0. What I mean by that is if you have 0 degrees Celsius, it is not the same thing as 0 degrees Fahrenheit, because 0 in temperature has a meaning. Whereas if we were to take, for example, money has a true 0. So say you have $5, or say you have $10. If you have $0, you have nothing. The same applies for euros. Say you have 2 euros, or say you have 4 euros. If you have 0 euros, you have no money. So that is what we mean for ratio data. They have a true 0, no matter what unit you use. So that is the difference between ratio data and interval data. And once again, ratio data could be interval data, and it has to be ordered. So each level up as you go up, so ordinal data is nominal, interval data is ordinal, ratio data is interval and ordinal. Okay, so keep that in mind when working with these different measurement types. So that is all for lesson 1. Thank you very much, and good luck studying.